So, hi everyone. Great to have every one of you here. I think my job is quite interesting because what I do at Vaadin is that, well, I do lots of kind of administrative things and so on, but the really interesting thing is that part of my job is to think about what goes into developing web applications, what are the things that are difficult there, and are there opportunities to make those things easier? And one of those things that already kind of 10 years ago we realized that, yeah, this is way too difficult, we can make it easier, is real-time updates in web applications. You could in one way say that, well, this problem was solved then around 10 years ago when we got WebSockets adopted in all the major browsers. But that it takes more than just the WebSocket. That's just the transport. You need to think about state management. You need to think about event buses. There's all these other things on top of that low-level WebSocket that you also need to think about. When we talk about kind of real-time updating things, I've got a bunch of different kind of use cases that we have identified. So this is the kind of stuff I'm talking about when I'm talking about real-time updating. First, we got to show the progress of something that runs in the background. So it's basically just updating that number as we get further. Then different kind of monitoring things, seeing kind of how things develop over time. So it could be a stock ticker, it could be some server utilization, those kinds of things. Then on the second row, we're getting to more kind of interaction between humans. So one thing is just to see who else is active in this application working on the same part. So, I mean, in a chat, it could be just kind of who is present in this channel or different kinds like things like that. We got locking, which is kind of the opposite. Then you're not collaborating, you're avoiding collaboration, you're avoiding conflicts, making sure that you can do some edits or something without being worried that someone else does something that conflicts with that. There's notifications. Basically, the application tells you that now there's something of interest for you, and then you can react to that. And then on the bottom line, we got these kind of really high-level real-time update collaboration use cases. One is chatting. Originally, this was chatting with other users. Nowadays, you're just as likely to chat with an AI. And then also, finally, in one way, the holy grail for many business applications is to be able to let users work together on whatever they're working on, some report or some order or something. We got this in kind of Google Docs and similar. And also, the thing is, we want to have the same in our business applications, in some cases, and in other cases, not so much. And when during these past years, I've been thinking about how can these kinds of things be made easier, because they are quite difficult. I've come to the conclusion that very much is just on this one single way of thinking about things. And that is, building up a little bit of tension here, the secret for real-time updates in web applications, or in any applications for that matter. It's sharing the UI state between those users. Because when you think about it from that point of view, then lots of things kind of fall into place. If you don't think about it, then you're kind of, well, we got this WebSocket and what should we do with it, and then things get complicated. But when you just think of it as sharing UI state, then it gets easy, and then the next question is, how do we do that? But before we get there, I want to get a little bit of input from you. So I have built this poll application for you, so you can scan the QR code with your mobile phone, or if you sit with only a laptop, then v-herd.eu/poll. We'll wait a little while for people to drop in. We see low right corner, 60 active users right now. I guess, yeah, 70. Once the number stops increasing, we'll say that most of you are there. 80, 83, yeah. All right, well, if you're not yet there, then just type in the URL. It will be visible all the time. So the first question, let's make it a little bit bigger for the screen also. How do you build the front end for your applications? So maybe you're using Vaadin, maybe you're using one of the three popular or most popular front-end frameworks, React, Angular, Vue. Maybe use some other JavaScript framework like Solid.js, Svelte, jQuery for that matter. That's a very popular JavaScript library for front-ends. Maybe do use server-side HTML, so time leaves and so on. Maybe you don't build web applications, but you actually do UIs for desktop or native mobile things. If you use React Native, then that's both reactive and desktop. Or maybe you don't do UIs at all. Why are you in the room then? I don't know, but that's up for you. Okay, so it seems React is most popular, Angular is quite convenient second, and then the other options are kind of behind. So that's kind of expected, but sometimes there are surprises also. Next question. How do you build, or do you build? Oh, now you found a bug in the application, -1 there. Interesting. So have you built, do you do this all the time? You're a real veteran in this. Maybe you have done it a couple of times, but not really so that you're kind of familiar with it. Maybe you are just planning to do it, or maybe you're not even planning to do it, and then I'm again wondering what you do here, but again, feel free to sit here. You might still learn something interesting. Okay, some people think it's fun to change their mind. That's also all right. Let's go to the next question then, final questions. If you don't do it, then why not? And now the synchronization broke. There we go. So why do you not build if you don't do? I mean, if you already do it, then that's fine. But otherwise, maybe you feel like you don't have the use cases. Maybe you feel like you could do it, you would want to do it, but your customer or your product manager or someone, they don't see the point in it. Maybe you feel like, well, we could do it, but I mean, the UI design gets more complicated and we don't really want to do that. Or maybe you think that, well, it would be really awesome, but I don't know how to do it. And if that's the case, then you're in exactly the right place, because I mean, my job here is to show how easy it is. All right. And this keeps fluctuating, so let's just close this thing so you don't get too confused there. I said clear. Thank you. All right. Thank you for that input. And now we get to the plot twist, because like you kind of noticed, we had a real-time updating application running there. You managed to find some bugs. That's also interesting. But kind of the rest of this talk, I'm going to walk through how to build exactly this UI. So we're going to go through this in 3 simple steps. First step is, let's just get the kind of basic UI up and running with state management, because like I said, state management is really the key here. Or maybe. Then, when we have the state management in place, we'll just make that real time by seeing how when we just share the right pieces of UI state, that lets us build exactly that kind of experience that it updates in real time. And then finally, because I mean, I know all the tricks, so I'm cheating maybe a little bit, but also showing how you can do things, or different solutions that you can do in your applications to do things according to the same way of thinking. So this is the basic UI design. I got this from one of our UI designers. I think it's a quite cool design. I'm not going to talk much about UI design here because, I mean, you're developers, but just a couple of reminders. First is that a bit like security, you can't just take an existing UI and say, let's make it real time, because that will, most cases, it will be confusing for users. Whenever something changes in the UI they have in front of them and they didn't do anything, they might very well be confused. What happened? I don't know. And because of that, you need to a little bit, kind of like in this poll, it showed how many people are active, so you realize, oh, others are also active. There were animations in the bars when things changed, and all these kinds of small things to help people realize what's going on. Also, if you got these kinds of use cases with kind of editing some form together or something, you often need to take into account what happens if I click save at the same moment when someone else does a change. I don't want that thing to be saved and so on. So again, requires a little bit more of UI design. Another thing to also take into account is assistive devices. How do people using screen readers realize what's going on when there are updates? So there are things that you can do on the UI design level, just mentioning them here, but not going to go through that in detail. The real key, though, is the state in this UI. So what we need to do when we got the UI design is we need to identify what are all the things that might change. What are all the things that you need to be able to recreate the same state again so that your user sees the same thing. And in this case, the most fundamental thing is the counts. So in this simple example, it's just three numbers. But there are other things that might be changing depending on how this view is implemented. So one is the states of the toggles. You maybe didn't notice, but you could cheat in the simple version I had. If you just vote for something, reload the page, it forgets that you voted for it, so you can vote again, reload, vote, and so on. So that's just a simplification to make things easier, but that's also show that just is this enabled or disabled right now. That's also part of the UI state that you might need to take into account. Then also, like we saw in the actual poll, is that I could, from my phone, I could change which is the question we're looking at right now. And that's in that way, that's also part of the UI state. And finally also, again, depending on how things are implemented, which are the options that are shown. It's kind of goes hand in hand with what's the current option, current question, but again, it's also basically some part of the UI state. So what we see here is basically, in this case, everything except the icons are kind of highlighted as UI state, but those are also derived from the options. So even that is in a way UI state. So let's jump straight into that and take what I got from the UI designer and add state management to it. So this is what we got. I got this really awesome React code from my UI designer. I got a really good UI designer who creates React for me. And just to kind of showcase, when I just change the class name, it becomes really ugly. So all the beauty there, it's also in the UI design. It's lots of CSS and nothing else to make it actually look like that.
Could you make it bigger?
The text or the text, I can zoom in a little bit. It will be tight to see, but all right. There we have it. And now we want to add state management to this. So in this case, I'm going to use signals for React. We're going to talk more about those later. So I'm going to create an object with all the options. So we got Vaadin, and the value here in this object use signal, it's just the count. So we have 5 in the UI design. Then actually, let's copy paste. And why is typing so much more difficult when you stand here presenting? Should ask Josh Long about that. React 2 and then Angular 1. And then now we got the state, but we also need to update the UI to use that state. So what we're going to do is loop over these, and then instead of these hard-coded options, let's copy one of them. We're going to map out all of them. So we're going to do some code here. We're going to loop over that. So object.entries for options, and then we map over that. If you're not super familiar with React, don't worry. This won't be in the test. Label and the signal, and then what we're gonna do is, for each of those, we're gonna return something like this. Let's see that it works. Yes, it works. So now we can remove these. And now we're just going to need to update all these parts to actually use the state that we have. So in React, we always need to give a key also to make the looping efficient. And then the class name is the label. We got the checkbox label is the label. and then here the number is the signal value. Now we're quite close. We're just missing the most interesting part, which is the width of these boxes also. So for that we're going to define, because I mean the width here is basically the max number divided by the, no, opposite. The number of votes divided by the max number, so then you get nice proportional bars. So to get the max number, we can do a computed signal. So that's a callback that is run on demand. And what we're going to do here is that we're going to take all the values from the signals in the state, values from options, and then map over those to get the signal and get the signal value. And that's values, and then we're just going to return math.max of those values. And let's throw in a 1 so that we don't divide by 0 by accident. And then now with this, actually we need to assign this const max votes. What do you say?
Max or sum?
Max. Because otherwise the bars will be quite small. Okay. They just need to be kind of in proportion to the others. So there's no point in doing the sum there. And then finally here, instead of this hard-coded 100%, we're going to do an ugly string here. So 100 times the signal value divided by the max count value, like so. Value. Still, what's wrong here? Oh, it's max votes, of course. Now it compiles. All right, that's it. So now we have state management here, almost, because it's still not updating. So final part here is on check change. Yes, we get an event, and what we're going to do in that event is if event detail, not default prevented, detail dot value. So that's a boolean, true if it was checked, false if it was unchecked. So if it's true, then we're going to do signal.value plus plus, and else we're going to do minus minus. And that's not what I wanted to do. So with this, now we got all the kind of regular state management working. So, I mean, nothing fancy here so far, but let's go a little bit into the theory about this. So what I'm using here is something called signals. Maybe you're familiar with it. If you use Vue, you're definitely familiar. It's just called ref there. If you use Angular, then maybe. If you use React, then maybe not. Signals are kind of becoming the de facto standard for doing UI state management in all of the UI frameworks, because it's a really cool idea. The way it works, a really simple case, we create a signal. A signal is just kind of, it holds a value, and then others can listen to changes to that value. So we create a signal, a count signal in this case, with the initial value of 5. Then we create something called a computed signal. So this is a callback that is run on demand. And what it does is it just takes the count value, multiplies it by 2. Nothing happens other than just creating this when we run this line of code. So it doesn't run the callback yet. Then we create something called an effect. An effect is the side effects, kind of taking you out of this pure functional-ish signal world and side effects that impact the rest of the world. So in this case, the side effect is that we are logging the value of the doubled signal. And immediately when this line is run, when the effect is created, that callback is run once, which means that it logs 10 for us. And the real magic with these signals is that when we just assign a new value to the count signal, then it logs 12. So the way this works is that when the effect is run, it's not just running the code, but the library behind the scenes also keeps track of which signals were read while this callback was running. And based on that, the effect sees that now I'm depending on the double signal. And when the double signal was run, it also detected that, oh, I'm depending on the count signal. So then when the count signal value was changed, it invalidates the doubled signal. So then it runs again because it has dependencies and so on. Then it runs again, it produces a new value, which is, well, 5 plus 1, so 6 times 2. And then because that value changed, it invalidates the effect. So then the effect is run again, and then that logs the current value of the signal, which is 12. So, I mean, it seems a little bit weird to do it in this way, but the thing is, with all the UI frameworks that support signals, this is hooked in with the rendering. So whenever any signal that you used previously when the thing was rendered, whenever that changes, the framework automatically knows that now it needs to re-render that part. And then depending on the framework, it can be very, very granular, or in the case of React, it kind of runs the whole render function again. Like we saw, there's these 5 very, very fundamental operations with signals. You can create them, you can read the value, that sets up a dependency if you run it inside a computed or an effect. You can write the value, that might cause some effect to rerun. You can create derived signals, computed, and then you can listen to changes using the effect. And these same things are available in all the top 3 popular UI frameworks. So in Angular, it's almost the same, just a slightly different syntax for how you read and write the values. In Vue, it's quite the same as ISO, except that it's called a ref, not a signal, and you use watch effect instead of just effect. React doesn't have this built in, but there's this Preact library that is kind of like React, but more efficient according to them. And their signal library is also compatible with React, and that's what I'm using, and I think it's a really awesome library to use. There's just one more thing there, and that's when you use signals just for kind of state management with React or Vue or Angular or something, then you don't need to care about any conflicts or anything, because, I mean, JavaScript is signal threaded and so on. But now what we want to do is to share the value of this signal between multiple users, and then you get the risk of conflicts. So in a real simple example, we got a signal with the value of 0, and then 2 different users, independent of each other, but roughly at the same time, do some action in the UI that causes us to run signal value plus plus. What we expect, of course, 2 users doing that increment, so we will get 2 as a result. But because of latencies and so on, there's a possibility that what happens is that both at the same time, because I mean what this plus plus does is just both read 0 as the value, both do 0 plus 1 equals 1, both say value equals 1, and then that's what's kind of the end of this, and that's not what we expected. So to deal with that, instead of just overwriting the value for these kinds of operations, we need to actually express what it is we want to do. We want to say that this is now an atomic operation. We've got an increment operation. So now when both clients, independent of each other, run this increment operation, then what we actually synchronize, it's not assigning a new value, but we actually synchronize that increment happened twice. And in that case, everyone receives that, oh, we incremented once, we incremented twice. So now the value is 0 plus 1 plus 2, so it's 2. Great. So that's important to keep in mind, and that also leads to the thing that we need to have different kinds of signals with different kinds of operations. For numbers, we got kind of increment, multiply by, those kinds of things. For lists, it's kind of insert first, insert last, remove an item, not by the position, because that might change. You think it's the first item, but suddenly something else was inserted, and then you remove the wrong thing. So you actually need to remove it by its kind of reference, where it is adjacent to some other items or something like that. Similarly for map or object structures, it's the same thing, kind of compare and set, remove, and these kinds of operations. rather than what you typically do with UI state management, that you just create a new object with a small part of the object changed, but otherwise the rest is the same. So by doing things in that way, we avoid these conflicts due to latencies, because all users are not always in sync with each other. Now we know everything to proceed to actually make this UI that we had real time. And to be able to do that, we need to synchronize basically these signal values, but so that all users share the same UI state. And the sensible way of doing that is through the server. If you're really, really fancy, you can do a kind of point-to-point thing, almost with WebRTC, but I think that's overkill in most cases, so just synchronize it through the server, that's completely fine. So to do that, we need to add some server-side logic, and the cheating part here, oh, this is really small now when I zoomed in. The cheating part here is that in my framework, this is built in your framework, it's maybe not yet. So what we can do here is we create a vote service.java. No, that's not a good, yeah, that's a good name. And what happened now? I didn't create it, let's try again. New file, vote service.java. Great, let's collapse that. And we need some annotations, because I mean, this is Spring after all. So we need to say browser callable. That's again from the Vaadin framework, that makes things available from this class from the browser. And then we need to say anonymous allowed, because we don't care about access control here. And then we need to have these server-side signals that we can then make available to the client, and through that the synchronization happens. So we need to create 3 signal instances here, 1 for each of the votes. So private final map, and that's from string, just the naming this case, to this number signal thing. Why don't you suggest anything? Options equals map.of. Maybe I need to import some things. That's the map I want, and that's the number signals I want. Yeah. So here we're going to have the same thing, Vaadin, no, not Vaadin, Vaadin. And this is Java, so this is new number signal with the value 5. And then we add the other 2 options. So we got React with initial value 2 from the UI design, and Angular with initial value 1 from the UI design. So now we got the state that we want to share. The next thing is that we want to make it available to the clients to use. So we're going to create a public method here, returning a number signal. Subscribe maybe. And we give it a name of the signal we want to do, and then we can here just do return options.get by that label. And now based on this, my framework generates TypeScript to call these things. That's something you might have to do on your own if you're not using my framework. In the front-end code, we move this out of the render function because we want to subscribe only once. We should really put it in an effect or something, but let's not make things complicated for now. Vote service dot subscribe to Vaadin, and now we're going to copy paste a bit again. So this is React, and this is Angular. And now it looks exactly the same. So what's the point? Well, the point is that I got another UI here also with the same thing. So now these should be in sync with each other. Yeah. When I vote for React here, it changes in the other one also, because what we're doing is we're synchronizing these 3 pieces of UI state. So all users who have subscribed through running this method, which in turn went through this server-side logic, they are now able to read these values, or kind of synchronize these values. So here you can do all kinds of access control. You can say that this method can only be called by people who are logged in or whatever. You can limit things like, well, this user should only get a read-only view, they can't change the data, and all these kinds of things. But at the same time, this is UI state, so it's not your primary business data in most cases, which means that it's kind of, you get by with quite simple access control in most cases, but there's always the possibility of doing things more sophisticated. We need to change one more thing here, because we have exactly the race condition I showed you with ++. So that's why this number signal has actually an increment by method. So let's use that instead, and here increment by -1 to kind of subtract 1. And I mean, this works in exactly the same way. You won't notice any difference until you are in production and you actually have multiple users at the same time, and you don't get problems because of it. That's this part of things. So what we did is we made this real-time updating simply by taking these pieces of UI state and sharing it. So now to come to the question, how do you do that? And I mean, obviously, I'm biased. I think the best option is to use Vaadin. There's a small gotcha. This is still kind of work in progress on our side also. So you might need to use some pre-releases and enable some feature flags and things like that. But soon, right? Software development, no pressure there. But at the same time, you can also definitely apply the same way of thinking in your own framework. So how do we do that? I think there's two different approaches. One is to do like we did, build your own state management kind of framework that you integrate with how you do things on your own. That's quite an interesting thing. I could do another 50-minute session on all the things to think about for that, so let's not go too deep into that. But the other thing you can do, which I will show in a short while, is to kind of manually synchronize the state over a WebSocket or something, but still apply the same thinking of, yeah, we're just synchronizing UI state. Let's not make it too complicated in that sense. But first, kind of, if you want to build your own synchronization engine, there's lots of things that you might want to think about. You don't need to memorize this slide either. It's a long wall of text. That's the whole point, to show that there's a whole bunch of things that you might need to take into account. First, you want to integrate with your rendering library so that it kind of works the same way as regular signals. Then you need to have these all different kinds of signal types, like number signals, list signals, and so on, to be able to do these fine-grained events. Event sourcing approach is something I recommend for the server part of it. So basically, the value of this signal, it's just the sum of applying all the events that have happened ever through history, and then you optimize with some snapshots and things. You need to take care of optimistic updating so that you get feedback to the user immediately when they click the button, but at the same time it takes a while until the message had gone through the server and come back and you see, okay, there wasn't any conflict. Transactions might be useful for things like, very classical transaction example. You got bank accounts, you want to transfer money between them. If you would do that by signals, which is maybe a bit weird, but then you want to be able to say that let's decrement by 100 on this account and increment on this other account where each one is a signal. And you want to be able to do that kind of, either both of those happen or none of them happens. Finally, maybe depending on your application, you also want to embed things with some kind of clustering infrastructure, because in the example I showed, that was just kind of in memory on the server, what are these three values? And if you got a cluster with multiple nodes, that's not enough. You need to also be able to synchronize between those. And then that also gets quite interesting, because then you are building a real distributed system. But enough about that. Let's show the simple, straightforward solution that you can get done in, well, let's say 5 minutes, maybe 10. So to do that, we should not cheat and use these number signals anymore. We should just do good, honest state management, say that these are now just integers. Integer, thank you. So we got 1, 5, 2, and 1. I said 1. 1. Worried a bit there. And now actually we want to be able to update these in real time. So we should wrap this in a new concurrent hash map. Like so, we just initialize with map.of. And then instead of subscribing to all of these, what I'm going to do, I'm going to cheat a little bit again, because my framework has built-in support for WebSockets. I just return a flux from this kind of browser callable class, and that opens a WebSocket for me. So to be able to feed things into that WebSocket, in the flux I mean, I need a sync. So let's create that in the constructor, public, almost, thank you. Like so. So we need syncs dot, and I want a many sync because I want a flux, not a mono. And I want a replay sync, and this is really the key magic here. The replay sync allows you or it saves previous things that have been sent out over that flux, so that when a new client joins, they can immediately get up to speed. With the replay sync, I also need to define how much to keep track of. In this case, we can make it really simple. We just keep track of the single latest value that has been emitted over this sync. So let's store this in an instance field. Let's initialize it somewhere. And this is now our sync. Well, let's call it limit. And the type is not object, but we're actually going to push out this whole map now. That's maybe not the most efficient way, that anytime one value changes, we push out all 3 of them. But this is again to keep this demo simple, because this allows us to do this kind of reinitialization in a really simple way with just the replay sync. Subscribing, now we shouldn't do this. We should subscribe to all of them at once. And what we're going to do is we're going to take the sync and just return as flux of it. And we need to change the return type like this. And then now, because now we're managing things on a lower level, so we subscribe through one method, and then we have another method for voting. So public void vote for some name, and just a delta here to say either +1 or -1. And what we're going to do, we take this options map compute if present, the name there, ignore the label we get there, and then we get a value, and then we do value plus the delta. And then finally we need to push out the changes, so we're going to do that once in the constructor. So we need this sync emit, try emit next, try just so that you don't need to catch exceptions. It can't fail in the case of a replay sync, but this is for all the syncs. And here we need to do actually map.copy_of, because otherwise the sync just see that we publish the same value again and again, so it doesn't do anything. And then we do the same emit also whenever we have received a vote. So that's all the server-side changes we need. Now we're going to compile error because I changed the signature of the vote service. So here we can actually just undo a couple of steps to this point. No, actually, let's undo a little bit more, like here. And now we need to subscribe to this. So to do that, we want to do that only once per instance of this component. So in React speak, that's use effect. With this very, very lovely syntax, we got a callback, and then we got an empty array. So what we're going to do here is that we can take this vote service, and then we call the subscribe method, and that returns kind of a client-side TypeScript counterpart of the flux that we returned. So then we do on next, and here we receive some update, and this update now, it's kind of, we returned a map from string to integer from Java, and the TypeScript representation of that is a record from string to number. So what we're going to do here is we need to iterate over these also, object.entries of the update, and then for each of them what? For each, yes. We're gonna again unpack the tuple, so we get a label and a value. And here we're gonna update each of these state variables one by one. Oops. So we're gonna do options dot, no. Okay, we need to do one more thing, because now TypeScript is very helpful, saying this thing can only contain these 3 keys, but since TypeScript doesn't know that the string we receive from the server is one of those, we need to actually tell TypeScript to shut up. So we say that this is actually signal number. And why do we have this thing there? Oh, we need one of these. All right. So now we can actually do this options label dot, and that's the signal, and the value of that is the value we received from the server. So with this, we're almost done. So now we can kind of not really synchronize things yet. And the reason for that is that here we also need to actually call that vote method, because that's the one that pushes out changes to everyone else. We see them ourselves because we also update the state locally. So that's latency compensation. So here we do vote service dot vote for label and increment by 1, or the delta is 1, and here the delta is -1. And now hopefully everything works. So now maybe I need to refresh a little bit. Maybe I need to. No, now it said something was redeployed. Nope. Oh, now it works. Don't know what happened there. It's kind of hot deployed things sometimes get interesting. So now we have again kind of when I vote in one of these, then the other one also reacts. And also very essential, thanks to the replay sync. Now when I reload, it also fetches, or kind of when it just subscribes, there's always for each new subscriber, it replays the latest thing that was pushed into that flux. And in that way, when I just subscribe, it gets that one update that sets the state, the initial state. That's it for the demo. Now I could take questions if there are any, and then we will just wrap up and proceed with something else. Do we have any questions? Everything was crystal clear, or then you fell asleep? Haven't seen anyone sleeping though, so maybe it was just crystal clear. All right, no questions. Let's just proceed. So to summarize, what we saw here today now is how to do real-time updates based on the thinking approach of let's just share some UI state. Let's share the number of votes, for instance, and then all the users that see that state, they kind of have their UI automatically updated because we hook in to the rendering library to actually do the updates. We did that in kind of 3 parts. First, just the basic state management implementation, nothing directly thinking of real-time updates. Yeah, maybe the UI design need to consider those things, but we implement it in exactly the same way as though there would be no real-time updates at all. Then to make it real-time, preferably we have a framework that just allows us to take specific pieces of the state, the signals in this case, and synchronize them with users. And in that way, it's really easy to make it real-time in almost no time. Or then you can do it with any library, any framework, with a little bit of extra bookkeeping. Basically, you use something like a Flux to push out updates. Easy way is just to push out whole state. Otherwise, you can also kind of send out incremental updates, but then you need to be also taking care of the initial state. That's basically all I had to say. So one more reminder, because it took me 10 years to figure this out. You get it basically for free now. The secret here is really think of UI, or think of real-time synchronization as sharing UI state, and then everything will be much easier than if you don't do that. So thank you very much, and have a great day.